Hi there, this is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. In the last video, we have seen about the construction of alkaline batteries. So we saw the key components as cathode, the anode, cathode which is the positive terminal, the anode which is the negative terminal, the electrolyte and the separator. In this video, we are going to see about the construction of this. So electrochemical reactions. The alkaline batteries operates through the simultaneous oxidation and the reduction reaction in a potassium hydroxide electrolyte. So the electrolyte that is used is the potassium hydroxide. The reaction at the anode is the oxidation reaction where the zinc is oxidized to zinc oxide which releases electrons. The cathode reaction, the manganese dioxide is reduced consuming the electrons which is released during the oxidation reaction. So the overall cell reaction is zinc plus manganese dioxide will give zinc hydroxide. So the standard cell potential is approximately 1.5 volt, making alkaline batteries suitable for most consumer electronics. Working principle and performance. How it works, the alkaline batteries has various steps, that is electron generation, current flow, ion migration, reduction process, continuous cycle. So in electron generation, the zinc atoms at the anode lose electrons, creating an electron surplus. Current flow. Electrons flow through the external circuit from anode to cathode, powering the device. Ion migration. The hydroxide ion move through the electrolyte to maintain the charge balance. Reduction process. The electrons combine with the manganese dioxide at the cathode. Continuous cycle. The process continues until the reactants are depleted. So how it performs? What is the performance features of the alkaline batteries? It has the nominal voltage of 1.5 volt. It's stable output throughout the discharge. This 1.5 volt is a stable output and it has a long shelf life. It has years from 7 to 10 years at least, and there's minimal self discharge. So this is an advantage of this, and it is 3 to 5 times that it has a greater energy density than that of the zinc carbon batteries. Advantages and also the limitations. First, we'll see the advantages. It has higher energy density. It stores 3 to 5 times more energy per unit mass than the zinc carbon batteries. Superior shelf life. It can be stored for 7 to 10 years with a minimal capacity loss. Better low temperature performance. It functions effectively down to minus 20 degrees centigrade. Consistent voltage output. It maintains a stable 1.5 volt throughout most of discharge cycle. Leak resistant design. Modern construction minimizes electrolyte leakage limitations. It has higher initial cost. So it is more expensive than the zinc carbon alternatives. Non-rechargeable. Primary cell design limits reusability. Environmental concerns. Contains heavy metals requiring proper disposal. Performance in high drain devices. Less efficient than lithium batteries for very high current applications. So these are the limitations of this alkaline batteries. So what are the real world applications? Alkaline batteries power countless devices in our daily lives, from household items to critical equipment. So it is used in the consumer electronics. Remote controls, torches, clocks, and portable radios rely on alkaline batteries for reliable, long-lasting power. Toys and games. Battery-operated toys, handheld gaming devices, and electronic learning tools use alkaline cells for consistent performance. Safety and medical devices. Smoke detectors, digital thermometers, and blood pressure monitors depend on the alkaline batteries for critical functionality. Did you know that over 10 billion alkaline batteries are manufactured globally each year, making them one of the most widely used energy storage devices in the world? It's really a surprising number. So, this is the mind mapping of the alkaline batteries. The construction, which we saw about the casing and cathode, what it contains, the electrolyte which is used, and the separator, and the safety, about the safety, that is the reactions at the anode and the cathode, and the chemistry, which is the reactions at the anode, and the working principle, how the oxidation occurred in anode and reduction in cathode. Advantages, how advantageous it is when it is used largely in the remote controls, long shelf lives and applications. It is safety, and proper disposal is very important. So these are about the primary battery, that is the alkaline battery, which is of more usable in the current scenario. Thank you.